The CASA info is up on Quarkus now. So if you go to Quarkus, if you just scroll all the way down to the homepage, there's a Facebook group for CASA. There's their group for this specific class. And there's also info on their office hours. So their office hours are 3 to 6 on Mondays, and it's pure like drop in. They don't have like a plan for you. It's just some very nice people sitting in a room waiting for you specifically from this class to come drop in and talk to them about cognitive science. And you can go in with something as vague as, I feel lost and I want emotional support. They'll help you with that. You can go in with something as specific as, I'm thinking about such and such for a topic for my essay. Is that a good topic? They'll be able to advise you about that. Or I'm curious about the cognitive science program at U of T in general and what kind of job I can get and how hard it is to get through the program and questions like that. They would be happy to talk to you about that kind of thing as well. So please do drop in. They're wonderful people and they got a lot of resources for you, a lot of helpful resources for you. So far nobody has, it's been 2 weeks, so far nobody has asked to come to my office hours. Again, just any time that you feel like talking to me after class, you're welcome to just hang out in this room and talk, and or we can go to my office and talk there. So just a reminder, if you want to come to my office hours, you are absolutely welcome. Just let me know. Okay. Any other kind of course business stuff before we dive in? Everybody pretty good? I'm currently working on, I'm going to post as soon as I can the topics for the first essay. I'm currently working on them. I'd like to give you something reasonably specific. It would be fairly straightforward for me to just say, write me an essay on categorization, memory, or problem solving, but that kind of leaves more of the burden of framing it on you. So I'm trying to frame some more specific questions for you right now, because that'll get you warmed up, take some of the intellectual burden off of you for the first essay, and leave it all for the second essay where you're coming up with the topic. So for your final, just a reminder, for your final essay in this course, you're going to be self-generating the topics. And they're going to be more in the first one is more of a psychology essay, second one's more of a philosophy essay. If you haven't read any psychology, the best preparation I can recommend for you would be to do the readings from this class, which are psych papers. So get used to reading psychology papers, get used to the format and the jargon and that kind of thing. So that's what I would recommend in terms of getting prepared. The first essay is not due until what, like July or something. It's certainly not due before the first test. So that's not the first thing you have to worry about, but it is worth getting the gears turning in advance of that. Okay, any questions about that stuff? Good. Okay, so we'll do a quick review and get into some new stuff. So recall last time we looked at a couple of theories of categorization. We're still in categorization. We're going to finish off categorization today, and tomorrow we'll move, next week we'll move on to memory and problem solving. We looked at two theories of categorization, the classical theory of concepts with this guy here, Aristotle, as kind of the main guy from that, the person who's most famously associated with it at least. He said that concepts are a kind of mental definition. So you've got in your head a set of necessary and sufficient conditions for anything, and if it meets those necessary conditions, if it has all of the necessary conditions, that's sufficient for it to be that thing, and if it doesn't, then it's not that thing. We saw some nice advantages of this. For example, this gives us compositionality, so the concept is made out of little Lego blocks, and if you want to combine concepts, he's got a really nice story about how you do that. You take the parts of those concepts and you put them together in some meaningful way. That's really nice. That explains how we combine concepts together. It also explains this rather remarkable fact about us that we have productivity, that productivity of being able to put together any infinitely complex set of concepts into a sentence, right? You have a sentence saying something true or false about the world, and you can produce an infinite number of those. That's a capacity that we clearly have, so any complete story about concepts should tell us how that works. That would be nice. And Aristotle's classical theory of concepts does that for us. So good. Of course, we also saw some problems for the classical theory. Mostly that this just doesn't seem to be how necessary and sufficient conditions just doesn't seem to be how most of our concepts work. Most of our concepts outside of formal languages, formal reasoning systems like geometry, math, logic, computer programming, There, the classical theory of concepts works beautifully. Everywhere else, and I think for most of us, everywhere else is much larger than those formal languages. This theory just does not capture how our concepts work. So all of you are perfectly able to use the concept game. You're able to identify things that are games and things that are not games. However, we tried and failed, like many intro philosophy classes have in the past, to come up with a set of necessary conditions for what a game is. And it's not just games, it's practically every concept that you work with that don't have real crisp definitions. Yeah?
We kind of like bash the idea of like a worm not being intelligent, but like it can make the categorization of like is food or not food. It's very stupid with respect to that. Like due to the limitations of our brain, is there like really an infinite way that we can categorize or describe something?
So productivity, this is on the notion of productivity. So is there any reason to think that we have an infinite number of things that we can do?
Or even understand,
yeah. Yeah, so the usual argument for this is just to look at conjunctions. So, or like counting. So I have the concept of 1 apple. I can have the concept of 2 apples and 3 and 4. And it's not that I could hold an infinitely not large natural number in my head. It's just that there's no stopping point in which I can conceive of number of apples going up and up and up and up. There seems to be, of course, there's biological limits to how long a sentence you could hold in your mind, but it's not a conceptual, it's not that your conceptual apparatus fails, it's that your working memory or your long-term memory or your voice would give out if you tried to say it or something like that. So you hit other biological limits much, much sooner than you hit the limits of your conceptual apparatus. That's the argument. You can produce infinitely long sentence, like infinite number of true sentences. Say, I am not a frog, and I am not a frog, and I am not. And you can just add negations, or you could add disjunctions. So I am not a frog, and I am not a pig, and I am not a crow. So you can produce. They're not interesting sentences, but there seems to be a number of ways in which you can produce just indefinitely large. Let's call it not infinite, but like unlimited, except for the biological limits of our ability to like say very long. Like eventually you just die of old age before you could say all the sentences. You would die, maybe the point is, you'd die of old age before you could say all the sentences that you could say. And there seems to be no problem for you to, especially when we're thinking about compositionality, it's not that there's 0 limits on the concepts you can put together, but there's this marvelous and hugely impressive capacity to put concepts together and get new concepts. So,
is it not maddening that we're starting from that massive, huge quantity, and rather from the little worm that can just kind of understand 2 concepts?
Yes. So it's much, much harder to explain our compositionality than it is to explain what a worm does.
How does this also extend to like self-referential concepts? Like you were saying, like telling a lie, I'm a liar and everything I say is a lie, but my last statement was true. That throws our brain for a loop. We
a little bit.
Conceptualize a paradox, but we don't exactly understand why.
We don't understand why what?
Why that doesn't work, why that makes us nervous, for instance.
I think I could give you an ad hoc explanation. So you could say something like, we like for sentences to be true or false.
Yeah.
We much prefer for something to either be completely true or completely false. It's easy to process, it's easy to think about. So when you get a sentence like, this sentence is false, it doesn't do that for us and you get a little, ugh, I don't really like that. So.
What I'm getting at, are there scenarios like that with our ability to conceptualize things that we just can't do that? Like it goes against our programming or design or our fundamental logic.
Yeah. So the claim of compositionality is not that there are no limits on your ability to conceptualize. This is a good clarification. It's not that, the claim is not that there's no limits whatsoever, because like just with like the natural numbers, like the natural numbers are infinite, but that's not to say that everything in the universe is included in the natural numbers. Like fractions aren't included in the natural numbers. So it's not that there's everything in that series, it's just that the series goes on and on. So we'll talk a little bit when we get to philosophy of mind about the possibility that there are some things that we just can't understand. So there's serious philosophers who argue that there are just limits to human minds, and maybe things like explaining how consciousness works are simply beyond those limits. So we'll take that the thesis quite seriously in the philosophy of mind section. Good. Follow-ups on this? Okay. So back to problems for the classical theory. We talked about how the broad consensus is, and I don't think I offered you a super tight argument that there's no necessary and sufficient conditions for games. The argument is basically empirical, that nobody's been able to come up with a satisfying list. And then the question is, if you're convinced that there are necessary and sufficient conditions for something like game, the question is, why are you convinced of that? What's your argument for there being such a thing, given that nobody's been able, given that huge numbers of people competent in the language who know how to use the word game have nonetheless been unable to produce it. So that's the argument against the central argument against the classical theory. We looked at one or two others. Here's another one, specifically the failure of transitivity. So classical theory says stuff like, if you understand the definition of dog, you understand that that definition includes that it's a mammal, and the definition of mammal includes that it's a living thing. So you should very easily be able to do all dogs are living things. That should be conceptually transparent to you. It should be easy, it should be straightforward. But then you ask these questions like, are car seats chairs? Yes. Are chairs a kind of furniture? Yes. Are car seats furniture? Ugh. Sort of. Not really. Right? And just the fact that anybody, so if you're perfectly fine with car seats being furniture, that's okay. The fact is that not everybody is. People are much less confident about this than all dogs are living things. So it looks like the transitivity at least sometimes fails, and the classical theory says it should never fail. So that's where we were with that. So classical theory of concepts, probably not going to do the job for us. So we moved on to the prototype theory. This is a theory motivated by looking at philosophy, looking at the work of Ludwig Wittgenstein against the classical theory, and it says, yeah, theories don't have crisp edges. What they have is a prototypical core, a set of features weighted by their relevance that says what are the most common things that the category has. Dogs are fuzzy, or like, so the prototype for cat they have fur and 4 legs and a tail and a terrible attitude towards life. And if you have a cat with no fur, you can have cats with no fur. There are those very weird gremlin-looking hairless cats. You can have a cat with less than 4 legs. They often lose legs. It's still a cat. You can have a cat that's with a sweet disposition. I know there exists at least some of those, right? So that doesn't disqualify it from being a cat. What the prototype theory tells us is that you can have vague boundaries around your category, and the closer you are to the prototype, the more people say, ah, yeah, that's exactly what that is. And that seemed to be borne out by some empirical evidence. For example, that people rate robins as more bird-like than penguins or emus or vultures, right? Those have less of the prototypical features of the category bird than the robin does, and that gives us this nice prototypical structure. People would investigate this by building those typicality gradients. So you'd ask people questions. How typical is this of a bird? And I'd give you a rating. And then you try to build the structure of the prototype by reconstructing people's typicality gradients from their ratings. And we worried quite a bit about this as an empirical process. We worried about confounds. We worried about confounds like how familiar you are with the thing, rather than asking, like, are people just saying the things they're familiar with, or are they saying the structure of their concepts? That's, I think, a legitimate worry here. Yeah?
How about like a category of something that's immaterial, like or a prototype of something immaterial, like math,
Yep.
or, I don't know, gravity.
Yep.
Like we are not able to usually perceive that, or even perceive math, but we can understand. How does the prototype theory align with that?
That's
Is everything a hidden feature with respect to that, or are we fully kind of creating theoretical features from what we know? Or
that's fine for the prototype theory, because there's no explicit requirement in prototype theory that the features be perceptually perceivable features. So one of the features of the number 3 is that it's an odd number. Oddness is not a thing that you can see. But like one of the features of a cat is that it's a mammal. I don't really think that I can see mammalianness. I don't know what that looks like exactly.
There are features of the mammalian.
Yeah, but it's a sort of inference that you make that it's mammalian rather than something that's like, contrast being a mammal with being blue or being square. Like those are things that you're literally, you can see where that's happening in your eyeballs that you're picking up those features. Whereas lots of the features in prototypes are more abstract, more kind of inferred than observed, that kind of thing. So there's no built-in requirement in prototype theory that the features that are being picked out are like directly perceptible features. Yeah? Good. And we saw some examples of that. So some problems for the prototype theory. How do we produce them in the first place? There's just no story given about that. But there was also this stuff about unstable typicality gradients. These typicality gradients that people are producing seem to change across contexts. Remember that stuff about a typical beverage for a secretary versus a typical beverage for a trucker. People give different answers despite presumably having the same beverage concept in both cases. Yeah?
But aren't those different concepts? Like,
well,
that truckers drink not different from beverage?
well, a typical beverage for, I suppose those might be different concepts, but then the worry with that is, that's one way of responding to that concern, but the worry with that is that there are an almost indefinite number of possible contexts, and what if you ever get in a situation where you have to say you've got an indefinite number of structures in your head, that's worrying, right? It's worrying when you need an infinitely long list of anything because we clearly have finite-sized brains. So that was the concern with, if you want to say, look, I've got a different beverage concept for, like probably none of you had ever thought before about the question of what's a typical beverage for a trucker, right? Unless you've got truckers in your family or your close social circle, like it probably just never came up for you. But you were able to generate, I bet all of you were able to generate some guesses about that. You had some notions about that. And that's either something that the concept was able to produce for you, or you've got a unique concept that you just never needed before and you called it up. So if that's the case, then you got this like enormous, almost indefinitely long, like astronomically large store of concepts that you've never needed and never used, and they're just waiting in the background for somebody to ask you, what's a typical beverage for an astronaut who's just built their first moon base? And you think, Tang. You know, like, why did I have that concept somewhere in my head? And you can give either answer. Like, if you think that you can get that list within a human brain, you could give that answer. Like, look, there's just separate prototypes for either of them. Or you could say, prototype theory has not given us a complex enough picture of how concepts work to show how they could be context sensitive like this. So prototype theory tells us it's just a list. The prototype for beverage is just a list of common features of that beverages have, weighted by their relevance. And maybe that's not what concepts are. Maybe concepts have more internal structure than that. And that's a notion that we're going to kind of deal with today. We're going to deal with another theory of concepts that gives them a little more structure.
So is the critique that it doesn't explain the productivity of categories?
In this case, it's I think productivity is a slightly different notion, but in this case, it's the context sensitivity of them. So your concepts behave differently in different contexts, and there's nothing in prototype theory that gives you the machinery for explaining how they do that. So it's related to productivity, but that's got a fairly technical definition, so we maybe don't want to use that word for it. Yeah, but you're on the right track, but yeah.
Do semantics of the word itself also affect the context of like how we see the rest of the scene in which we're kind of comparing the object to or viewing that? So I talk about a person as a dog versus a dog. Like does that, like I clearly know that in the scenario, like the meanings of the features that are assigned to them are different. But is that an alteration of the concept, or is that at what point does it go from semantics to concept? Kind of running like that.
So I would have said that semantics are part of so the semantics of a word are have to be captured by the concept of the word. So my concept of pig is, it has to produce the semantics. The semantics are just like the meaning of the word, right? So the meaning of the word beverage has to be somehow encoded by my beverage concept, right?
Does the meaning of the word not change in relation to the context or something?
It does, it does. And that's a really important and interesting thing that humans do, is that we use words in a context-sensitive manner, and unclear how to make that, how to represent that using prototype theory. Yeah, good. Okay, what else did we talk about? Oh yeah, we talked about the failure of compositionality, this big spoon, little spoon, metal spoon, wooden spoon thing. Let me just give you one more example here, just maybe to make it clearer. So here's another one from Osherson and Smith that we didn't talk about last time, but it's the same idea. It's the same failure of compositionality. So what are the typical, ask people, what are the typical features of a pet? They say things like they're cute and fuzzy and cuddly, and you like to touch them, and they're nice. You know, that's the, you know, you like them, you form a bond with them. What are the typical features of a fish? Well, they're scaly and grayish or pinkish or something like that. They live underwater. Now, what are the features of a pet fish? And all prototype theory gives us for conceptual combination is really just to either push those lists of features together or maybe pick a few of them out. So a pet fish is something that's fuzzy and scaly, and you like to touch it, and it lives underwater. Is that what a pet fish is? No, no. When you put pet and fish together, you get something new, right? They're usually brightly colored, you don't touch them, they don't know their names, they don't bond with you, they don't even make eye contact with you, right? Unlike all of the other pets, usually you have some kind of connection with them, something like that. So just smashing those lists together, or maybe like taking one feature here, one feature here, one feature here, one feature here, doesn't seem to explain how we get pet fish. Yeah? It's just that there's just a more complex, what's going on here is there's just a more complex interaction between the concept pet and fish than a simple summation of the two concepts. That's the failure of compositionality. We're not given any story about how they get put together. Yeah?
I've always considered pet fish more akin to like an arts display.
An arts display, right, yeah, yeah.
Would that be due to the way I put together my category of like art display?
I don't know. I don't know how that happened in your head.
Colorful.
They are, yeah.
They're meant for looking at.
Yeah, yeah.
They're in the main room.
Yep. It's true. It's true. I don't know how you came across that notion. It makes sense. It makes perfect sense. So pet fish is equal to moving, living, you know, installation piece or something like that. Yeah. Yeah. So anyway, so the point is just it's really not clear, according to prototype theory. They haven't given us a story about how we do this thing, this really important and interesting thing of combining concepts together and getting a non-linear combination of the two concepts. Yeah.
Isn't that applicable to only like the level of kind of abstraction, whether you're talking about like superordinate or basic or subordinate? So I could just say like they're both animals. And it's like it's still, they can be nested with each other. It's like they're both active, you know, they both interact with me. So like at one point it fails of like, okay, a fish, if we get into the real nitty-gritty feature details of it, it fails in comparison to the nitty-gritty details of like a cat or a fuzzy pet.
Yeah.
But it still satisfies the requirement of compositionality if you go up the chain more and more.
Okay, so if you get to the most abstract features, then yeah. But we don't want our theories to just succeed once in a while. We would like them to tell us the whole story about cognition, of course. Yeah? All right. Yeah.
I feel like that still breaks down when you consider like pet rock.
Pet rock, yeah. It's not fuzzy, it doesn't interact with you. It's not even attractive to look at, it's just a rock.
Or a fish.
Yeah, yeah.
There's something like defining that like petness. It's like there has to be something fundamental to that. Like,
I feel like you could just keep assigning weirder and weirder things, the word pet, to just cut off whatever you might try and claim is like the basic notion of pet.
Okay, well, I'm sure there's a class at this university on the philosophy of pets. We could do this all day, but let's keep going. Let's keep going. Okay, so we got just one more thing to talk about in this quick review, or two more things, sorry. We've got this stuff about generating typicality gradients where there shouldn't be typicality gradients. So typicality gradients were supposed to be our tool for investigating the structure of concepts, the structure of prototypes. And if you ask people sensible questions like, what's the most typical vegetable, they'll give you sensible sounding answers. And people took this to be evidence that they were really probing the structure of concepts. And then when you ask them questions that aren't sensible, like what's the most typical odd number, is 7 or 57 the most more typical odd numbers, they'll give you typicality gradients again when they really shouldn't be, because we know the structure of the concept odd number. It's any number not evenly divisible by 2, right? Like, that's what it is to be an odd number. There's no typicality gradient to be had there, yet people were producing them perfectly happily. So that casts some doubt. These weird typicality gradients cast some doubt on the ones that looked like they intuitively made sense. Yeah?
But can't you just have like a number that you see more often? Because like you see 4 more than 8 or 6.
Yeah, and that's,
Less typical.
well, so typical of the category. And if what people are answering, if when you get a number for the typicality of the odd numbers, if what you get is just how often you see the number, that's sort of a familiarity effect. You're just like, that's how familiar I am with this instance of it. Then that tells you that what you're measuring when you've got these ill-defined categories probably isn't the structure of the concept. It's how long has it been since you saw a car? How long has it been since you've seen a boat? Yeah, so if what we're really measuring with these typicality gradients is just how familiar, how comfortable are you with these different instances, then it's not telling us about conceptual structure. It's telling us whether you live near cars or boats, right? Sorry, yeah, follow up and then yeah.
But couldn't that just be your definition of prototype? Because that's not that far off a prototype. Like we make our prototypes.
Well,
Familiarity.
but that's not so just like how long has it been since you saw something isn't enough to fill out a conceptual, like the concepts that we use, right? Like that's just a measure of like, you can very simply measure how long it's been since you saw a car or a boat or skis or a horse. But that's not going to give you the concept of a vehicle, right? You want your concepts to do much more than just tell you how long it's been since you saw a thing. So that would be the word with that. And yeah.
I think that it's because they were asked how typical something is, that they would come up with an answer.
Yeah.
Because I don't think people normally consciously think about, oh, how typical is this number, how typical is this number,
Sure.
that number.
Sure.
But once they're asked, that's and if something as independent as just odd number and even number, they'd be okay with coming up with an answer.
Yep.
I still think subconsciously we don't think about like how typical a number is.
No, sure. So this is just an explanation for why people would be willing to do this.
Yeah, because they were asked to.
Yeah. But that again, that sheds doubt, that leads doubt to this as a method of understanding conceptual structure. If people just say stuff, like people will just say random numbers or like numbers that don't have much to do with the structure of the concept when put in this task, that tells you that the task is probably not ideal for measuring conceptual structure, which is what people thought they were doing. Yeah? People thought they were understanding the structure of our concepts by getting these typicality gradients. They thought that this was telling us how our concepts worked. And if you're producing just gobbledygook when on command, then that should make you worry about the methodology, I think. Yeah.
Could the problem be that like typical is poorly defined here?
Could be. Yep.
Like if you really spent 45 minutes explaining to somebody that typical means it is a member of the class and atypical means it's not a member, and away for some reason,
Yeah.
if you gave them this test, you might get things much closer to
Maybe.
1.
Maybe. So in that case, you should get on these well-defined categories, you should get 1 for every member. Yeah.
I was wondering if it could be the fact that, like, perhaps what we see on a day-to-day basis, it affects the way that we think for future on in the rest of the day. So, for example, like, if the people who are taking this test on TV had seen an ad and it had a phone number on it, the numbers that were in the ad that reoccurred more than once would be more typical to them than any
Yep.
other numbers within a list. So like, for example, like right now, it is completely subconscious normally, but just sitting here, I looked at cognition and I see 3, 3, 3, 3. Those are the only numbers that I see.
Yeah.
And so to me, they're more common than the number 6 or a 2. Like that 2 I barely even saw. I only really saw the 3s in there.
Yeah.
Do you think that like reoccurrence within a day's period of time or prior to this experiment would have really affected their own definition of typicality?
Could be, and there's a lot of psych literature showing priming effects. So if you can subconsciously prime somebody to be thinking about a topic, and then if you ask them later, they'll generate that later. So that's a potential confound here. It should even out if you're asking 100 people for their typicality gradients. Presumably they've seen different numbers during the day, so it should kind of average out. But yeah.
Is this then more regard to an issue with typicality or just with the prototype theory? Because if we can't nail down what typicality is, it's like, I have no baseline. I can't point here.
Well,
this 3 is typical. Like I can measure it. Like I can.
but the typicality gradients were supposed to be the evidence that you use to build the empirical basis for the prototype theory. So if you,
This is based on a bunch of subjective people that could have seen, done, been exposed to anything.
yeah, I take it that's a problem for the prototype theory. Yeah. So generating a problem. So if we show that typicality gradients are actually just familiarity, or they're subject to massive priming effects, or people don't understand the instructions, or whatever, you've shown that the evidential basis for the prototype theory is much thinner than you'd hoped it was.
In mathematics, like everybody can usually agree that like pi is a non-repeating decimal number, it goes on and on. But mathematicians have found, for instance, there are patterns within pi's, and there are little bits and pieces where they kind of have structures to them. Like there is some kind of typicality or some repeating structure, or at least some kind of structure, at least bits and pieces. Is there not something fundamentally typical to something? Like whether something repeats itself in nature, whether something...
I'm sorry, I don't think I follow the...
I'm trying to say, like, we're basing our typicality rating off of what we can measure from people, but is there a fundamental typicalness to something in the universe?
I strongly suspect not, because what makes them, specifically because of the context effects that we see in the unstable typicality gradients seem to be a very intelligent thing that people do. And what they're doing is treating their concepts as context sensitive. And if they're context sensitive, that means that there's not just an objective fact about what's the most typical beverage. There's just not an objective fact about that. There's a most typical beverage in a context, perhaps. But that's different than saying that there's just a structure to the concept. Okay. So we got a lot of stuff to do today. So I'm going to skip over this linear separability stuff. We'll come back to this when we do AI. This is going to be a problem from some early AI programs. So let's just skip over that and get into some new stuff, okay? Okay. I'm glad we got that discussion. That was good discussion, though. This is, again, this class kind of rolls tutorials and lectures into one thing. So it's good that we're discussing this and kind of clearing up questions and issues about the last lecture. That's why I'm doing this review mostly. So in case you're sitting there thinking, what are we doing? We learned this already. This is part of the plan, okay? Okay. Okay. I got one more problem for prototypes that I want to explain to you. It is by far the most technical and weird problem for prototype theory. So hang on. We'll try to do this in a not spectacularly mathematical way, but there will be a little tiny bit of math involved. So this is a critique from Osherson and Smith, the same Osherson and Smith from before. And their issue is prototype theory makes it hard to evaluate the truth of quantified sentences. What does that mean? Okay, so one of the reasons that you want to one of the reasons you want to have concepts is because concepts let you do things like evaluate the truth of sentences. Like, the bottle is on the podium. That's a sentence. Presumably, what you do is use your bottle concept and your podium concept and try to test whether that sentence was true. Okay, so testing the truth of sentences. Now, what about the truth of quantified sentences? Quantification is saying things like, all x's are y's or some x's are y's. So if we want to test the truth of a quantified sentence, that task is something like saying all cats are mammals. All cats are mammals is a quantified sentence. You want to be able to, I mean, we as humans absolutely need to be able to say things like that and be able to evaluate whether they're true or false, right? So if your theory of concepts doesn't show you how that's possible for us, your theory of concepts is missing a really important thing of, like, we're not just going around categorizing things for the fun of it, right? That's not why we categorize. We categorize so that we can understand true or false claims about the world, to test true or false claims. So you want to say all electrons are negatively charged, or all classrooms in this university have chairs. Those are quantified sentences, and you have to be able to evaluate their truth or falsity. So that's something that our theory of categorization should help underwrite. Yeah? Okay, so, and Osherson and Smith are going to make the argument, they make it in this paper, that prototype theory makes some really weird predictions about our quantified sentences. That it makes predictions that don't make any sense in terms of quantified sentences. Okay? So I'm going to go through this argument. It involves what's called fuzzy set theory. Fuzzy set theory. It's very cute and fuzzy. So standard logic treats any sentence as true or false, right? It's either completely true, completely false. Prototype theory categorizes things by degrees. So that seems to be a bad fit, right? I should have said in this slide, standard set theory categorizes things as either in the category or out of the category. I shouldn't have said standard logic, although set theory is arguably part of logic. So standard set theory, you're either in the set or you're not in the set, right? Anybody who's done set theory, there's not like, well, this is sort of in the set. Just like prototype theory does. Prototype set theory says, well, skis are kind of a vehicle. They're sort of a vehicle. Okay? So logic is largely built on set theory. If we use logic to evaluate the truth of our sentences, that's worrying, right? Because prototype theory does not fit with standard set theory. So what we need to do is combine prototype theory with some kind of logical system that allows us to evaluate the truth of sentences, right? We need to combine, so if we have standard classical logic, we say all birds have wings, and we look at the set of all things that are birds, and that whole set is things that have wings, then we have a perfectly reasonable way of sort of combining our theory of concepts with our theory of logic to evaluate the truth of sentences, and that was a quantified sentence. Prototype theory looks like it makes that hard because it gives us answers like skis are kind of a vehicle. Okay? So here's a really natural way of trying to solve that problem. Here's a really obvious, not obvious, but like, here's the best shot that we have at dealing with the problem that prototype theory, with its fuzzy categorizations, fits very poorly with set theory, standard set theory. What we're going to do is move to fuzzy set theory. Fuzzy set theory categorizes things by degrees. So, it's my favorite example. In fuzzy set theory, so consider the class of bald men and non-bald men. There's two classes, men who are bald, men who are not bald. Now, where on this chart do you draw the hard and fast line between those two classes? This male pattern baldness chart. Maybe you don't need to. So standard set theory, you're either in the set or you're out of the set. Fuzzy set theory allows us to say, well, you're mostly in the set. You're kind of in the set. You're extremely in the set or extremely not in the set. Yeah? So it says set membership is a matter of degrees. And that's good for prototype theory, right? So if we want to combine prototype theory with some kind of logical system, fuzzy set theory seems like a really natural fit, a really natural way of producing sentences that we could evaluate for truth value. So, Osherson and Smith argue that the very plausible combination of prototype theory and fuzzy set theory unfortunately actually generates a bunch of problems. So this thing that we want out of our theory of categories, or categorization, we want out of our theory of categorization the ability to say how we evaluate sentences, and standard set theory is not going to give us that. If we got prototype theory and standard set theory, that's not going to work. We need something on the logical side of this. Fuzzy set theory is a really natural way of going about this, but unfortunately they make the argument fuzzy set theory and prototype theory gives us some very counterintuitive results. They're not going to work well together, and there's not an obvious alternative. So that's the basic argument. So far, so good. Okay. So let's talk about fuzzy set theory. We'll do a little bit of fuzzy set theory, and then we'll come back around and talk about how this produces problems, okay? So this is Fred. Say hi to Fred. Fred meets the grizzly bear prototype with a value of 1. So if we're going to categorize Fred, say we've got the category of grizzly bears, Fred meets that category with full value. So say 1 is the most you can fit into the category. Say 0 is the least, 1 is the most. Fred's a grizzly bear, so he meets the grizzly bear prototype perfectly. Yeah? Okay. Here's Alfred. Alfred is a polar bear. Hi, Alfred. He fits the grizzly bear prototype with a value of, let's say, 0.8. I'm making these numbers up. The numbers don't matter. Let's assume that we can ignore all of the problems with prototype theory, like unstable typicality gradients, coming up with values, all that stuff. Let's ignore all that and imagine that we can say how well a single object, like Alfred the polar bear, fits the category grizzly bear. Now, Alfred has not all of the properties of grizzly bears, of course. He's a polar bear, but he's got most of them, right? He's got big paws, and he's got a snout, and he's a bear, right? So he's got most of the features that are typical of grizzly bears. So we'll give him a 0.8. Okay. And this is Sam, Sam the squirrel. Sam meets the grizzly bear prototype with a value of, I'm just making it up again, let's say 0.1. Although Sam has some properties in common with a grizzly bear. He's got fur, got claws, I guess, tiny little claws. Most of the properties of grizzly bear, let's say Sam doesn't have. Okay, so this is the basic idea of fuzzy set theory. You got a category, and you say, is this object in the category? And you can sometimes say, yes, definitely, and sometimes say, mostly, and sometimes say, nah, not really. Yeah? Yeah.
I don't really agree that you can do that even with prototype theory, because like having a polar bear, I don't think you could rate it 0.8 similar to a grizzly bear. And if you're talking about the grizzly bear category, because having a snout and having all those features aren't really important features to match the prototype. I don't know, because
okay.
You're talking about grizzly bears, you're not talking about bears in general. Grizzly bears have a different set of distinct features from...
So you're saying they don't have the necessary features to be a... But prototype theory doesn't believe in necessary and sufficient conditions. Prototype theory believes that so in prototype theory, your grizzly bear concept is really just a list of features. And some of them are, it's got fur, it's got claws, lives in North America. Okay, so if that's... And you can be missing some or most of them. If that's disastrously wrong, if that doesn't work at all, prototype theory kind of doesn't work at all. So the argumentative move that's being made here, so consider the argumentative move that's being made here, and it's a really good move. In general, this is a really good move to make. If you want to destroy somebody's theory, the best way to go about it is to take on as many of their assumptions as you possibly can. So what Osherson and Smith have done here is say, okay, let's imagine that I can build a typicality gradient. Let's imagine that I can build a context-insensitive rating for how well a certain object fits a category. Let's imagine that we don't have any of these weird problems with prototype theory, and we can just stick a number on it. So The problems with prototype theory are very real, and we shouldn't forget about them. But for the purposes of this argument, they're saying, let's suppose all of that works even. Yeah? Does that help your concern at all?
But I feel like if you ask people how typical of a grizzly bear is a polar bear, most people would give it close to like a 0.1 or something.
Okay, the numbers are made up. The numbers don't matter.
Yeah, but
Does
I
that-
don't even think it's close to reality, really, the numbers.
Would you be happier with 0.1?
Yeah.
Okay, it doesn't matter what the numbers are. Okay, okay, sorry, I saw your hand first. Yeah.
Why this judgment though, like if everything is somewhat in relation to the polar bear, doesn't that category which the polar bear category exists in, isn't it filled with like infinitely other objects inside it that are related to varying degrees of certainty to the polar bear? Like doesn't that
Yep.
just defeat the purpose of having a category in the first place?
No, no, because if something is 0.0000001% a polar bear or grizzly bear, that's not really in the category. Yeah?
But it still is according to this. Like it's just
Well,
very, very small.
Yeah, it's not completely not in the category, but it's not deep in the category. So what this is an implication of prototype theory all along, that things get categorized by degrees.
So at what point does it become a grizzly bear?
Well, there's no hard and fast cutoff. Again, this was right in the core of prototype theory, that there's not one point where it's either in the category or it isn't. It's the fuzzy boundaries thing. And we had to have that. That's a necessary feature of the prototype theory, because one of the problems with classical theory was that it had these hard and fast boundaries. And we found that that was a hugely problematic feature of the theory. So having fuzzy boundaries is one of the things that we wanted out of. It's one of the design features of prototype theory.
But aren't only the boundaries fuzzy? So if you ask someone, is a squirrel a grizzly bear, they'd say no, and you'd give it a 0, right? It's only the boundaries that are fuzzy.
Well, so the number is generated by the following method. A prototype is just a list of features, right? So it's a list of features weighted by their importance. The number of those features that you have times their relevance is the number that you get here. Yeah? I mean, these are good questions, but these are questions for the prototype theory, not really for this argument. Yeah.
But I think prototype theory does it not give like a threshold or some fuzzy threshold. It says that, okay.
Nope.
All right.
Nope. It's just you get the rating of however many features that you share, that's what your rating is. So if you share 0 features, so suppose your prototype for a bear has 20 features, and you hold up a rock and say, is this a bear? And it shares none of the features, then you get a 0. So that's one way to get a 0. That's one way to have an absolute 0. Yeah, yeah. It depends how many features there are in the prototype. If you got 100,000 features and one of them has mass, then anything that has mass is like sort of in the category. If that's not one of your features, then no. Okay, okay. So back to fuzzy set theory. So here's what's called a characteristic function in fuzzy set theory. This is a function that takes the set, so C of the set, and that's the characteristic function of this set for x, which x is some specific object. Okay, so the x is an object, so C of the category grizzly bear for Sam the squirrel, we've decided is 0.1. Yeah? Oh, is that, so you say for this given category and this given object, how much does that object fit the category? We've given Sam a 0.1. Again, the numbers, I'm absolutely just making up these numbers out of nowhere. So, okay, yeah.
Is this like symmetrical with respect to, let's say, the category of squirrels as the polar bear just as then by this regard?
Depends on how many features are in each prototype. So,
If we can just define features arbitrarily as an infinite amount of features that we can give to something,
yep.
If we can define an object that has an arbitrary or infinitely large amount of features that we can give to it, and we can then compare it to another object that has an infinitely large amount of features that are arbitrary to it, like, how can we ever come to a conclusion of this is 0.1 in comparison to this, and this is 0.8 in comparison to this?
A devastating critique of prototype theory. There needs to be you would need to give some very clear story about how you come up with a feature list, and recall that that's one of the problems with prototype theory, is that they don't tell us how you come up with these lists. Yeah? Yeah.
It's worth noting that there are reasonable ways to compare infinite sets. You can say like
Yep.
half of all integers are even.
Yep. Yep. You can use.
How, I'd say, correctly reduced an infinite set to some finite thing that people can easily understand.
You can use measure theory, which is a perfectly good mathematical tool for comparing the size of even real valued infinities. Yep. Okay. Have we got characteristic function? What this does is just tell the C of something given X is just how characteristic the object is of that category. Yeah? Okay. If that's fine, let's take 10 minutes. We'll come back and I'll deliver the actual argument. So I've just been setting you up for this argument. Come back in 10 minutes. I'll give you the argument. We got as far in this argument as talking about what we need, what we would like. So just to remind you where we're at in this thing, you need some way of using your theory of concepts to talk about how we evaluate the truth of sentences. That's where we started, right? You don't just go around the world categorizing things. You go around the world trying to determine true facts, right? True facts about the world, partly based on the categories of things. So we need something to combine with prototype theory in terms of a theory of logic or a theory of reasoning or something like that. We found that standard set theory seems to be a poor fit. We thought maybe fuzzy set theory would do a better job. And then I just started telling you about fuzzy set theory. So we talked about characteristic functions. So the characteristic function given a category of an object is how well that object fits the category. We've been making up numbers. Let's say the squirrel is 0.1. Okay, now the next thing to get is quantified sentences, evaluating the truth of quantified sentences. So here's a quantified sentence. All grizzly bears live in North America. So that's a sentence. It's quantified because it says all. So it's a sentence about all of the objects in this category also belong in this category. So in standard set theory, that's really easy to evaluate. So if suppose this inner circle is a set of all grizzly bears, the outer circle is a set of all things that live in North America. If the inner circle is inside the outer circle or doesn't go outside of it, then the sentence is true, right? If the set of all things that are grizzly bears is strictly contained within the set of all things that are inhabitants of North America, then the sentence, all grizzly bears live in North America, is true. So no problem. Here's how they do it in fuzzy set theory. Okay, so that top line, suppose X is Fred. Fred's our grizzly bear. And we've got a characteristic function for Fred, given the set of grizzly bears. And we've got a characteristic function for inhabitant of North America. So suppose we plug Fred into that. So that sentence, all grizzly bears live in North America, is true, just in case for anything that you can substitute in for X, the characteristic function of it being a grizzly bear is less than or equal to the characteristic function of it being an inhabitant of North America. Okay, take a minute. Yeah.
Shouldn't it be like comparable, like shouldn't the new X be comparable to that of Fred rather than like it being less than an inhabitant of North America?
Sorry. So the new X, so this X, we've got Fred plugged in for one of our X's. The idea here for the quantified sentence is for any object that you can plug in for X. So we say for any given object. So for this chair, is the characteristic function of this chair being a grizzly bear less than or equal to the characteristic function of it being an inhabitant of North America? And then we do this chair and this bottle. We do Fred, we do me, we do every object in the universe. This is how quantified sentences work. So say, for any object in the universe, is it always true that its characteristic function of being a grizzly bear is less than or equal to the characteristic function of it being an inhabitant of North America? Yeah?
If Fred is also like graded as like a 1, like as a prototype of North America, as well as being a grizzly bear,
Yeah.
like wouldn't that then make Fred the prototype of North America as well? Inhabitants of North America?
Yes. So in that case, they both come out as 1, and it's true that it's less than or equal to.
But then doesn't that kind of defeat the, like, because then you could have multiple prototypes of inhabitants of North America.
We're assuming there's only one. Why does this give us multiple?
Well, I guess it's more of a criticism of what prototype theory itself.
Yeah.
But like if you had squirrels, like 100% squirrels live in North America, right? So then the inhabitants of North America, the prototype of inhabitants of North America would be squirrels.
So
there'd be multiple prototypes for one particular category.
well, okay. So let's think about the prototype for inhabitants of North America. What are the important features of inhabitant of North America? What pick out something as belonging to that category?
It has to exist in North America.
That's pretty much it. Yeah.
But does that really reflect how people think about prototypes? Could there be multiple prototypes for a single category? That's what I'm asking.
If there are, that's disastrous for prototype theory.
Okay, so then there's criticism of prototype theory.
Yeah, yeah. So in this case, let's just assume that the prototype of inhabitant of North America has exactly one feature. Its feature weight is maximum, and it's just is this thing in North America? Yeah? Is that okay? Yeah.
Yeah, to respond, I think it would be more accurate to say that there are multiple things which match the prototype.
Right, right. So there's lots of objects that would get a 1 for inhabitant of North America. I live in North America, you live in North America, we all live in North. Given that we're all in North America right now, I'm fairly confident, we all get a 1 for inhabitant of North America, yeah? So that means that this is true just in case if it's being a grizzly bear is less than or equal to being an inhabitant of North America, for anything that you can plug in there, then the quantified sentence is true. To make this argument work, I'd have to make it intuitive why that's the way, and this is just to be clear, this is a very standard way of evaluating quantified sentences in fuzzy set theory. So given fuzzy set theory, this isn't something that they made up for the purposes of this. Fuzzy set theory is just a branch of mathematics that has its own justification. So in fuzzy set theory, here's how you evaluate quantified sentences. So all they've done is taken this abstract bit of math and hooked it up with prototype theory and shown that it does this weird thing that I'll show you in a minute, okay? So I'm kind of asking you to take it on faith. Without teaching you fuzzy set theory, I'm not sure I can make that formula super intuitive, but if you can take it on faith that this is how they do it, we can move on. Is that okay? Is this good? Okay. So for Fred, this works. So Fred is a 100% grizzly bear, 100% living in North America. That means the C of grizzly bear for Fred is less than or equal to, in fact, it's equal to, the C of being an inhabitant of North America. So here's another example. We got Alfred. Here, Alfred's living in North America. Say he's up in northern Canada. The C of Alfred for grizzly bear is 0.8, we said before, which is less than the C of him being an inhabitant of North America, which we can call 1. So that's, once again, if you plug Alfred into this formula, it works again, because it shouldn't affect whether you think it's true that all grizzly bears live in North America if Alfred lives in North America. It's just irrelevant, right? So long as it's less than the C of Alfred being inhabited in North America, comes out as true for that one, right? So quantified sentence, it's true if just for anything you can plug in here, it comes out as true every time. Yeah? We got 2 questions, yeah.
What about all tomatoes are fruits? Because then it would be like a normal tomato would have a 1 for being a tomato, but then like a 0.6 for being a fruit. But all tomatoes are still fruits, because you know that tomatoes are fruits.
Well, that's in that case, people are judging that tomatoes aren't fruits. Yeah.
But then aren't you judging Alfred isn't a grizzly bear? I don't see.
No, we're judging that he's this doesn't what we're judging here is that it doesn't falsify the claim all grizzly bears live in North America. Right? That's all this slide is meant to show. Yeah, is it quick? I would like to move on because this is getting hairy.
Take it out of North America. Does this like whole proposition fall apart? Like,
Well, that just makes it. No, hang on. But that just makes it false that all grizzly bears look in. So that's not a problem with the theory. That's just false.
But like if say like fruit was your instead of seed inhabitant of North America, and tomato was your instead of grizzly bear, if you have like 0.8 for fruit and then tomato is 1, it doesn't, that equation doesn't hold anymore.
Well, that's just categorizing tomatoes as not fruits. Let me get to the argument. Let me get to the argument. Don't pick holes in it until I've actually presented the argument, okay? Okay. Because I know people are getting frustrated with this right now. So, okay. Here's the argument. Here's what's supposed to be a problem for prototype theory after all this time. So, suppose we've got Sam the squirrel living on Mars. Here's a problem case. Here's Osherson. And by the way, I did not make up this example. This is Osherson and Smith's example. So let's say that Sam's characteristic function of being a grizzly bear is 0.1. And being very, very far from North America, Sam's characteristic function of living in North America is less than 0.1. Let's call it 0.05. And if that's not below 1 for you, you can put him on Venus, you can put him on Alpha Centauri. Put Sam as far away as you need to get the characteristic function of Sam living in North America lower than the characteristic function of being a grizzly bear. Okay, so what just happened there? Now, this inequality doesn't hold. So we've found an x for which the characteristic function of it being a grizzly bear is not less than or equal to its characteristic function for being an inhabitant of North America. What that means is that Sam the squirrel on Mars has somehow falsified the claim that all grizzly bears live in North America. That shouldn't be, right? That shouldn't be relevant to evaluating whether all grizzly bears live in North America, right? Intuitively speaking. The presence or absence of squirrels on Mars is not super important to deciding whether all grizzly bears live in North America? I take it? Yeah.
Isn't that, I mean, why, I'd say why not? It could just be that grizzly bear is just a really poorly designed category.
Okay. Okay.
It is actually falsified.
So you're willing to bite this bullet and say that the presence or absence of squirrels on Mars is relevant to deciding whether all grizzly bears live in North America?
Well, I mean, prototype theory has a lot of flaws.
Okay, yeah.
One of them
It's true.
is that, I mean, you have like these like infinite possibilities for like what is contained within a category. So I don't think the category would be reflective of how actual humans or like thinking things make categories. But if we're to go based off of the assumption that like this is fuzzy set theory, the problem that we have is this squirrel somehow falsifies that grizzly bears inhabit North America. It's like, well, technically, the squirrel is kind of, sort of a grizzly bear.
It's a little bit, according to prototype theory.
It's living on Mars, and technically, it doesn't exist in North America.
That's a bold concession. That's a bold concession. I think Osherson and Smith didn't expect you to be willing to accept that conclusion. They think that conclusion is so unpalatable that you're willing to throw out prototype theory.
I agree with Osherson's initial motive in that I don't really think prototype theory is the answer.
Right. Yeah.
Wait, why does it have to be less than the grizzly bear less than the inhabitant?
So that's the bit I think I'd have to teach you fuzzy set theory to explain. And I didn't prepare a slide on that. Sorry.
Is it just because it's like inside the set of North America?
It's analogous to that, yeah.
But couldn't like inhabitant North America be like a characteristic of the grizzly bear, not an encompassing? I mean, I guess it's the same thing.
I think, yeah, it gets more complicated if you try to nest the two categories that you're comparing, for sure. Yeah, read the Osherson. They'll give you a little bit more. Read the. I think that was the reading for today. So check it out. They'll give you a little bit more explanation for why they think this is and like basically this is just the standard way of evaluating quantified sentences in fuzzy set theory, and they just sort of import it into their theory. Yeah. Wow, you bit the bullet. That's very bold. Okay. If we're willing to accept that this is not how people think, then like when you're thinking through whether all grizzly bears live in North America, the presence or absence of squirrels on Mars doesn't actually factor into how our processes process. then I guess the argument gets where it was going. Not the way they hoped it would get there, but yeah. Okay. Yeah.
I feel like this is just showing that fuzzy set theory isn't compatible with prototype theory.
Yeah, yeah. So that's what they've, one way of taking this is to say, okay, Osherson and Smith, you said fuzzy set theory would be a good combination. Maybe it's not. Maybe there's some other theoretical apparatus we could use here. They certainly haven't given us a survey of all of the possible ways of doing this or shown us why any other way. So what they did was say, regular set theory, that's not going to work. Here's the only other thing, fuzzy set theory. Fuzzy set theory doesn't work, the end. So if you might be happy to say, like, look, we just need to expand our horizons here and come up with a better theory. So yeah, good. So we've got a few possible responses to this. We could just say, sure, Sam's a kind of a grizzly bear, and therefore Sam shows that not all grizzly bears live in North America. Or we could say, look, this is clearly we just give up on prototype theory from the beginning, so we don't even have to think in these terms. Or we could say, look, maybe fuzzy set theory is not the end, but is not the way of dealing with this, but that doesn't show that there is not a way of dealing with this. So several possible responses to this. Okay. So broadly, in summary, Douglas Medine had the following to say back in 1989 about prototype theory. Prototype theories imply constraints that are not observed in human categorization, predict insensitivity to information that people readily use, and fail to reflect the context sensitivity that is evident in human categorization. Rather than getting at the character of human conceptual representation, prototypes appear to be more a caricature of it. That's his claim. This was back in 1989. By the way, prototype theories are still under research. People are still working on these, trying to make them work. So this is not the case that people just gave up on prototype theory. And in fact, I think I mentioned before, if you open up a psych textbook and they ask you look up how do concepts work, they'll probably tell you some story much like the prototype theory. So this is not the end of the prototype theory story. What I tried to give you is just sort of an overview of what's going on in it and some of the major problems with it. Is that fair? Okay, let's take a step back now. So let's zoom out a little, because we've had a frustrating series of failures, haven't we? I mean, it's not like we were coming up with these theories, but it's been annoying. I'm sure it's been at least somewhat annoying to see these theories advanced and then knocked down again and advanced and knocked down again. So one thing that is reasonable to do after you've had a series of failures, and this is very general, is to try to figure out what's common between your failures. This is actually a pretty good strategy for diagnosing what's going on. So here, let's think about some shared presuppositions of the classical and prototype theory, the resemblance theory as well, because it's very much like the prototype theory. So everything that we've talked about so far has made the following two assumptions. Concepts are feature lists. Concepts are just lists of things that the thing being talked about has. Everything that we've done so far has worked with this as a presupposition. Maybe that's part of the problem. Furthermore, what concepts do, another supposition, what concepts do is just to describe or label the world rather than try to help to explain the world. I propose to you that those are quite different activities. So all of prototype does is just list off a bunch of features rather than tell you about the structure of a thing. So maybe those shared presuppositions were part of the issue that we were having. Maybe those suppositions that seemed really obvious, like this, one of the reasons why I gave you the classical theory is because this supposition that concepts are feature lists is exceptionally old, exceptionally widespread, and very, very intuitive for most people. But maybe it's wrong. Maybe that's part of what's been tripping us up this whole time. So maybe, instead of being disconnected lists of features, our concepts contain some kind of internal structure. That's a thing that's been missing from all of our theories. So the Gestalt psychologists talked about this like a century ago. The notion that when you're perceiving the world, you're not just perceiving a bunch of unconnected bits and pieces. What you're perceiving is a connected whole. Hopefully everybody can see the two ways of formulating this image as a whole. There's a duck and there's a rabbit. Yeah, okay, good, okay, good. So this is this image comes from the Gestalt psychologists who investigated the way that we perceive the world as a series of structured wholes. And in a way, people were giving the psychology researchers evidence that this is what their concepts were like. So they would say, what are the features of a table? And people would say things like, well, it's got sturdy legs that hold up a flat surface so that you could put stuff on it. Now, what they just gave was not just that it has legs, that it has a top. They gave a causal that is sturdy, right? It's good at holding things up, and a functional description of a table, that it's for holding things up. So it's not just a description, it's a causal functional whole. Right? So people were giving this kind of description. When you ask what's a bird, what's a table, people were giving causal functional descriptions, right? Things that have to be a structure, like when you say this is a chair, why is it a chair? Because it's for sitting on. Why has it got the causal properties that it does to support that function? You're not just listing off features of the thing, individual, isolated, atomic features. You're describing the way the features come together as a structured whole. Okay. Part of the problem with capturing this, and the psych researchers would just edit out that stuff. They wouldn't record the fact that it's causal or functional. They'd just say, ah yes, strong legs, flat top. That's what a table is, right? Part of the problem here is that it's much harder to put into words the causal functional unity of a thing than it is to put into words the features. So if I say, what are the features of a bird? Well, it's got a beak, and it's got wings, and it's got feathers, and it flies. Okay, I've listed off a bunch of features. So if I put on the table in front of you a beak, and some wings and some feathers, and I throw it all up in the air, you don't go, aha, a bird, right? What that lacks is the causal functional unity of a bird, right? The wings are attached to the feathers because that helps it to fly so that it can go eat bugs and continue to be alive, right? All of the parts of the bird are meaningfully integrated into a functional unity. Right? It's not just that it has wings or that it has legs. It's that the wings help the legs like stay together as a whole, right? Yeah.
Is that functional not unity also dependent on the goal? Like we
absolutely.
A certain way.
Yeah.
Like,
yeah.
if you then extend that to say like natural kind of things, like what is the goal of a bird versus the goal of a table?
So there's a lot of literature on that actually. So Kant writes about this actually. So Kant, and we'll come back to Kant when we do philosophy of mind actually. So the goal of a living thing in some sense is to stay alive and to continue its species. Not necessarily to personally reproduce, but so like, for example, most ants never reproduce. Almost 99.9% of ants never reproduce, probably more than that, but they keep their species alive. You can ask functional questions about the parts of a living thing, for example. So, and this is something that at no point in biology did biologists stop using this functional language. So what is the heart for? The heart is for pumping blood. Why does a tree have leaves? The tree has leaves to catch the sunlight. Why does it catch the sunlight? So it can produce the tree, right? So there's these kind of causal functional loops in living things.
How does that not suffer from the issue of like I'm defining the goal for a table thus the characteristics, the functional characteristics come out of it. And I'm also defining the goal for an animal, but I've given that goal to it. I don't know what the goal for the animal is.
There's a literature called the enactivist theory of mind, Evan Thompson's Mind and Life, that argues, just as an example, that argues that what characteristic of living things is that we generate our own goals. So the tree's goal, it's not me telling the tree that its goal is to stay alive. The tree's goal is to stay alive. This is controversial. I'm probably a weird person to ask about this because my PhD advisor was Dennis Walsh, and Dennis Walsh is one of the only people arguing for, like, one of the rare people, not the only people, one of the rare people arguing that there are actually purposes in nature, specifically in living things. It's not a popular view, but nonetheless, I got indoctrinated in it because he's my PhD advisor. So I likewise think that living things have purposes built into them, that they have their own goals, and goal making and goal breaking is one of the things that makes us intelligent and makes us alive. But that's a controversial position that many, many people do not agree with. So yeah. Okay. So, but okay, to draw this back to concepts. So one way of perhaps diagnosing the failure of all of the theories that we've looked at so far is that they treated concepts as though they were just lists of features, and actually concepts have a kind of internal structure and internal unity that makes them coherent in a way that lists of features are not coherent. Remember when we started off this thing, we were talking about categories versus sets. A set is just a list, it's like a collection of things. A category is supposed to hang together in some important way, right? That was the whole goal of this discussion, was to understand how categories work. Categories are supposed to be unified somehow. They're just not just a collection of things. And maybe it's unsurprising that when we dig down into what a category is, that it has this kind of unifying synthetic connective quality to it. So, okay, that all sounds very nice, Corey. How are we going to make that into a theory? Again, the Gestalt psychologists were studying this stuff 100 years ago, but here's a much more modern version of this. Let's call it the theory, or the micro theory. So if you go anywhere but U of T COG they call it the theory. I find that to be a weird and clunky name, so we're going to call it the micro theory. Basically what the micro theory says is that a concept is a little micro theory. It's a little theory that you have about some aspect of the world. So the structure of a concept, this thought goes, is the structure of a theory. And a theory is clearly not just a list of features of the world, right? When you learned physics in high school, you learned some Newtonian mechanics, you didn't just learn mass, force, volume, acceleration. Like, that's not how it worked, right? What you learned was a collection of rules of inference. That if you have this much mass, it's got this much gravitational attraction. And those rules were linked together into a tight unity, right? The law of gravitation has something to do with the law of momentum, right? Newton's three laws fit together in this important way, right? They are connected such that when you make an inference using one of them, it can lead to or feed from an inference from the other, right? So they're a set of rules that are connected. This is a bold hypothesis, and this is, again, good cognitive science, because what they're doing is saying, maybe we can take something from philosophy of science and learn about psychology, right? So what they're doing is saying, let's think about how science works, and maybe that's how our minds work. So this was originally proposed by Morton back in 1980. So concepts are like little theories, and those little theories are trying to explain causal, structural, functional features of the world. That's the view we're going to look at now. So Alison Gopnik, who was, I think she might have been at U of T when she wrote this back in 1988. conceptual and semantic development as theory change. So she asks, what is a theory? Theory, she says, is a set of rules of inference governing the manipulation of theoretical entities. So when you learn Newtonian mechanics, you learn how to make inferences using those rules. The laws of Newtonian mechanics are kind of rules you can use to manipulate the theoretical entities that you're talking about. And what theories do is explain the world rather than just describe it, often by citing the causes of things. So maybe that's what our concepts are like. Furthermore, theories can change as new data comes in. So Gopnik's work was largely on infant development. So let me tell you a really short story right now about infant development. And the idea is, as infants are developing their concepts about the world, what they're really doing is acting like little scientists. So take, for example, the concept of object permanence, or just objects. Okay? So when a baby is, like, you know the peekaboo game, right? You hide your face and the kid's like, wow, you're back again. You disappeared. You're back. Wow. So at age 4 to 5 months or so, infants can respond to objects that have disappeared, right? So if you shut off the lights, they're still able to reach for the object. So that they have the idea at around 4 or 5 months. Before 4 to 5 months, the world to them is just unique individuals just happening and happening. After 4 or 5 months, you shut off the lights or you cover their eyes, they'll still reach for an object, right? Or if you turn back the lights back on, they're not surprised to see the object still there. Okay, so it's not that they have no notion of object permanence, but they have a very rough notion that the object's still there if you can't see it. At 5 to 6 months, babies can do the following. So if it goes, so my bottle's going to go behind the screen, and you're all going to make the brilliant prediction that it's still there, right? We're all doing this inferential thing where, whoa, it's still there. So for a baby earlier than 5 months, so what they do when they're studying babies, they evaluate how interested they are by how long and hard they look at something. So from 5 to 6 months, if you take an object and put it behind something and then it reemerges, the baby's not that interested because it's like, yeah, that's what I expected to happen. That's not